Hey guys, sorry, I am, like 30 seconds late because as I didn't have my glass of water ready to go. But I've got my water, we are good to go. And I'm also sorry, I barely announce these live streams anymore. I'll tell you what was happening though. It was like a Sunday afternoon. I was hoping the weather was going to be really nice. And because the weather wasn't so nice, I was like, oh, I'll do a little bit of YouTube comments. I'm still a few days behind. I'm only on Thursday's YouTube comments. And I was like, I don't really want to do YouTube comments. I'd way rather actually like hop on here and do a live stream. And I thought, why not just do a few questions? It's not going to be a really long live stream or anything, but I thought it'd be a nice thing to do. So I'm right now, I don't make much from doing it. I just love doing these live streams. They are so much fun and I really, really enjoy it. I'm afraid my mum actually did comment on it. Mama Bicen is now going to become a bit of an icon. I didn't even notice, but the Mama Bicen, which is the fake account, has got like a profile picture where they've taken my photo and they've put like curly hair on it. My mum would be so mad if that's what she thought people look like. My mum, it does not look like that at all. My mum is English and my dad is Turkish, but my dad is never on the live streams because he's less of a like technology kind of guy. Oh, I know what I was going to do. I was going to do a little bit of a poll. So I'm going to, just to kind of get us started, I'm going to do a little poll and I want to find out which of these topics is your favorite. So we've got something to kind of talk about as well. So I've just launched it. We've got a choice between differentiation, trigonometry, vectors, and logs and exponentials. I kind of have an idea of which one I think is going to be people's favorites, but we will see. Someone said, are we going to meet Mama Bicen today? No, we are not going to be meeting Mama Bicen. She lives in London and I am obviously up in Manchester. So got some nice comments through from Maisie and Rowan. And we've now got Karan, who is from my Discord server. He's now finally been upgraded to moderator because I've finally got around to adding him in, which was good. Do I listen to Meov? I don't know who Meov are. I have no idea who Meov are. But, oh my God, my mum is actually here now. My mum is actually here. Now, you better be careful, Mama Bicen, my real Mama Bicen, because I've got some moderators here. So if you say something I don't like, I'm gonna get you blocked on the channel. So you better be careful. You better not say anything that like actually embarrasses me. I don't know if you've noticed that my mum is actually here. So she is actually just on her way. It's my auntie's birthday. So she's on her way soon to my auntie's birthday in London. And I just was on the phone to my auntie. I just sent her some flowers for her birthday. So yes, anyway, we should actually get on with something, but I want to see what the most popular topic is. At the moment, with 230 votes, differentiation is coming out on top. Why do you think differentiation is so popular? I knew vectors was going to be at the bottom. I knew vectors was going to be at the bottom for this. And yes, Ali has said hello to the real Mama Bicen. Ali is from the Discord server as well. So we are going to get on with some questions. Also, what do you think? Should I do hat or no hat? I think I'll probably do hat for this. I think I'll probably do hat. The hair's not looking good. The ears are looking big. Okay, let me see. Maybe I'll tuck the ears in. Anyway, I'm getting distracted. This is why you should never have like a mirror or a camera near you when you're doing any work, because you just check everything else out instead, okay? Shall I do a new poll? Yeah, I'm going to do a new poll, hat or no hat. But I can't do it until I close this one. Okay, I am actually going to do the hat or no hat poll. Obviously, differentiation was the most popular. Let's do a different poll. Let's actually do hat or no hat, and then we'll get on with some stuff, okay? So I'm going to have to lean over here. Hat or no hat? Hat. No hat. And then we'll see once we get people voting on this. We'll actually then get on with some stuff that we've got here. Who suggested the hat or no hat poll? Was that Karan? Yeah, good. Okay, so it looks like I'm going to be keeping this hat on unless things are starting to change, because people are enjoying the hat. We're going to be doing, in today's live stream, by the way, we're just going to look at 4 questions that are related to trigonometry. And the thing that's really interesting about these 4 questions is they don't look like they're necessarily about trigonometry, but there's obviously like trigonometry like involved in all of the questions. And I was expecting there to be way more trigonometry questions than actually come up. Okay, I'm going to keep the hat on because we've got 65% of people saying to keep the hat on. So, okay, we're actually going to do some stuff. we are going to do some stuff. If anyone comes up with any other kind of polls for partway through, let me know and I will do another poll and we'll see like how things are going with that. But let's actually get started with this trigonometry live stream. I'm not going to be on for too long today because I have got a nice Sunday roast booked. Even though I'm vegetarian, I'll still have a nice Sunday roast. So that is not going to keep me here for too long. I'm just going to do a few of these questions that we've got here. Democracy has spoken. The hat is staying on, but I'll leave that up to see if how many people actually end up doing this. So where are we at? Where are we at? Let's say we're going to do this trigonometry live stream. I've just taken it from the 2022 paper. If you haven't seen it, I've also done a calculus live stream that's kind of from these questions. There was a couple of the calculus questions that had some stuff to do with trigonometry as well. But out of the 4 questions that we've got, this is the only kind of pure trigonometry question that it kind of actually comes up. The rest of them are trigonometry, but coming up in other kinds of spaces that we've got here. Okay, so we start off with this important part saying that we kind of can't use too much of the calculator, but we're going to make sure we do use that correctly. We say that given that this thing is true, show that this thing is true. And I haven't seen a question like this for a really, really long time where they just want you to do some stuff to do with the addition formula. So I hope you do know the addition formula by heart. I'm going to do the addition formula onto this 2 sine x minus 60. So there'll be a 2, a sine x cos 60. And because it's the sine one and there's a minus here, there's going to be a minus. Now, I would say the mistake most people might make here is they might forget to put the 2. Obviously, because the 2 is there, it's going to be multiplied by both bits. And that will be a 2 cos x sine 60. And then on the right-hand side, there's no 2, so it's just going to be cos x cos 30. Plus, though, this time, because there's a minus here, so it's going to be a plus sine x sine 30 for this. I'm going to try not to use my calculator as much as possible for this kind of thing. So cos 60 is a half times 2 is 1, so this is just sine x. And I know that if cos 60 is a half, sine 60 is root 3 over 2, but it's being timesed by 2, so it's just root 3. So that's minus root 3 cos x. And then cos 30 is root 3 over 2, so that's root 3 over 2 cos x. And sine 30 is a half, so that is a half sine x. Now, if we want to, we could divide by cos now to create tan. I'm probably going to do this, putting the sine on one side, the cos on the other. Pretty easy question, I think, for a question 14. I'm going to do sine x take away half sine x, which is a half sine x. I'm still laughing at the fact that my mum has finally appeared in a live stream and that she had the audacity to comment and say that she was here and the true Mama Bicen. I'm now going to do the root 3 over 2 cos x plus the root 3 cos x. So it's just a root 3 over 2 plus a root 3, which is 3 root 3 over 2 cos x. I can multiply both sides by 2, so I can get rid of this and get rid of the half. And I can also divide by cos x so that I just get tan x is equal to 3 root 3. Okay, that was an easy first part of this question. Let me see if there's anything else that's going on in the chat with this. Okay, no, it's all looking good. So we could have divided by cos x. We can't divide by cos x at the beginning, by the way. This was a really important question from someone. Why can't we divide by cos x at the very beginning? It's because this argument and this argument are different to each other. So you wouldn't actually create a tan. You would be saying, okay, it's tan of what, x minus 30? 60? Which one would it be? Because the arguments don't match. That's why we couldn't do that at the very beginning. Now, this is the part I want to kind of look at, because when you look at this, it's not immediately obvious what x has been replaced with, because I want to know what is this x going to be when I'm trying to solve this equation from 0 to 180 of 2 sine 2 theta cos 2 theta plus 30. And it does have that word hence, which makes me think I want to use what's happened earlier on in this question. So we play a game of spot the difference. Well, that means that when I play spot the difference here, this x minus 60 has been replaced with a 2 theta, and the x minus 30 has been replaced with a 2 theta plus 30. So it's not clear what the x has been replaced with. So what I'll do is I'll show you this. For the yellow part, the x minus 60 has become 2 theta. That's for the yellow part. And for the blue part, the x minus 30 has become 2 theta plus 30. So I think I have actually seen this correctly answered in the chat. But this means that the x value is 2 theta plus 60 from the yellow part, and also 2 theta plus 60 from the blue part. So this means when I take this statement, tan of x is 3 root 3, the x will get replaced with a 2 theta plus 60 that we've got there. And I can see that in the answers that we've got. Hannah's said that, B has said that. So we're kind of doing good for that sort of stuff that we've got there. So this means for part B, instead of it being tan x equals 3 root 3, it's the tan of 2 theta plus 60 equals 3 root 3. Now they want it between 0 and 180. They want theta between 0 and 180. I'm going to just get this 2 theta and 60 because I know people quite like doing that. So I'm going to double it. So it's between 0 and 360. And I'm going to add a 60 on. So I get 2 theta plus 60. Meaning I need my solutions between 60. And yes, I'm using the calculator to do 360 plus 60. I'm looking for solutions between 60 and 420 for this. So I'll make sure I'm in degrees mode. And I'll just do the inverse tan of 3 root 3. So 2 theta plus 60 is 79.106. How do I find other solutions for tan? Because you don't want to subtract 60 and divide by 2 until you have found all of the solutions inside that range that we've got there, okay? Yeah, other methods will be valid if they're not mentioned in the mark scheme. Yeah, good. For tan, it's just adding 180 that we've got there. The person who said 360 minus the answer, that's just for cos that we've got. So for my second answer, I go to have a sip of water and I'm immediately putting it down because I'm in the middle of talking. I'll add 180 and I get 259.106. If I add 180 again, I get 439, which is clearly outside of that range that we've got there. So I'm just going to now solve this equation by subtracting 60 and dividing by 2. So I will do the second one. I'll subtract 60, I'll divide by 2, and that is 99.6 degrees. And for the first one, that's 79.106. I'll subtract 60, divide by 2, and I get 9 point, did it want one decimal place? Yeah, one decimal place. 9.6 degrees for this thing. What do you think is a sensible thing to do once you have got these answers? What do you think is a sensible thing to do once you've got these answers? I have to have so much water. When you talk like this as a teacher, I just constantly talking. Yeah, that sounds good. Just substitute back in, check and see that it works. Perfectly fine to do that kind of thing. If you really wanted to, you could do the solve n thing in the calculator. And I suppose if you wanted to, you could actually do it to this equation just to make sure that we are perfectly correct. But I know we're correct with this because we've got them right, haven't we? We've got them right. We've got the 9.6 and the 99.6 degrees for this one. So it's quite nice. We've had one question that's just like a standard equation solving thing. The second one is not nice because it looks so weird, but we're going to try and think through why they put this question in. And of course, it's a modelling kind of question from paper 2 that we've got here. And it's a Ferris wheel question. They love questions about Ferris wheels. I feel like I've seen so many of these things here. If you only use the solve n method, you will lose method marks. Solve n is not there to do the work for you. It is there to check your work, okay? I think it's in my calculator video about how to do this. So figure 4 shows the sketch of a Ferris wheel that we've got. The height above the ground, so the height is above the ground for this, h meters, of a passenger on the Ferris wheel t seconds after the wheel starts turning is modelled by this equation. Looks weird because of these modulus signs, but the bit inside is just a trig graph. It's just a sine bt plus alpha. The a does the stretching in this direction. In fact, you can tell me, I'll tell you what, I've just said what the A does. I want you to tell me in the chat, what does the A do? What does the B do? And what does the alpha do? When we're thinking about something that's written like, I don't know, we've got it as A sine BT plus alpha. This is a bit like having AF of BX plus alpha. Let's think about what those things do in terms of graph transformations that we've got here. Because I'm not even going to read the question. I want to get the theory of this nailed before we read through what's going on. So we've got an alpha is to do with some kind of shifting to the left. Very good. A is a stretch parallel to the y-axis. B is stretches, but I want to kind of see a little bit more detail about what people are saying with B. The person who's given me that so far is Rex2, saying that B squashes it horizontally. There is this idea of a stretch horizontally, but I think I really wanted this idea that I've seen from Saurav, who has said it's 1 over b, like the kind of stretch factor is 1 over b. And I'm seeing that now from Eshana and from Huds as well for this. So really, really good stuff. We might not need to use all of that stuff, but we have now got the theory of what all of those things do. So A is a stretch like this, scale factor A. B is a stretch like this, scale factor 1 over b, and this alpha is a translation of minus alpha 0 that we've got there. So figure 5 shows a sketch of the graph of h against t for 1 revolution of the wheel. This is 1 revolution. It goes up, it goes down, and it comes up a little bit at the end because probably the passenger is going to get on here. So it's going up, down, it goes down a little bit lower, and then it comes back up again. That's what that weird little flick at the end was. I remember when I first saw this, I was like, is that a typo? Is that something that they've kind of put into the exam paper and that wasn't supposed to be there? But it is supposed to be there. So the maximum height of the passenger above the ground is 50 meters. The passenger is 1 meter above the ground when the wheel starts turning. The wheel takes 720 seconds to complete 1 revolution. Find a complete equation of the model given the exact value of A, the exact value of B, and the value of alpha to 3 significant figures. So I'm going to deal with this first bullet point, which is that the maximum height of the passenger above the ground is 50 meters. Now, I know they've got these modulus signs here, but if they didn't have the modulus signs, we know that it's sort of talking about a sine graph. The maximum value of a sine graph is normally 1. The maximum value of this passenger above the ground is 50 meters. So immediately, what I can look at the chat, I knew this was going to be happening. I can just say that A is 50 because it's previously at 1, it's being stretched all the way up to 50 for this part. Now we can deal with either of these bullet points in whichever order we like for this, okay? We can either deal with the passenger being 1 meter above the ground when the wheel starts turning, or the second one. I'm actually going to do the second point. I'm going to say when the passenger is 1 meter above the ground, so when h is equal to 1, t is equal to 0. When the wheel starts turning, the passenger is 1 meter above the ground. So this means from the equation 1 equals 50, the modulus of 50 sine b times 0 plus alpha. Get rid of the modulus. I don't really need to worry about the modulus because if you think about a sine graph, the beginning part of the sine graph is exactly the same as this. So the modulus sign hasn't done anything interesting. The only time the modulus is doing something interesting is for this little bit where it flicks up at that bit. So I'm not going to worry about the modulus signs here. I'm just going to go straight into solving the equation like this. So I have 1 over 50 is equal to the sine of b times 0 plus alpha, which is the sine of alpha. So I need to make sure I'm in degrees mode, which I am. I'll do the inverse sine of 1 over 50. And I want it to 3 significant figures. Alpha is 1.15 degrees to 3 significant figures. Now, they don't give us any more information apart from this strange bit about the wheel takes 720 seconds to complete 1 revolution. Now, 1 revolution, they've told us, is this, gosh, this whole pattern of the graph that we've got like this, okay? Yeah, this is 2022 that we've got. So, I always get a bit uncomfy when I'm sat doing these. Let's think about what 1 revolution would look like of a normal sine graph, okay? A normal sine graph is like this. This is 360 degrees. When we talk about a revolution, we're normally saying this is 1 revolution. But clearly from this diagram, 1 revolution is just going like 1 section of the sine graph. So we're not actually talking about the whole thing. And this would be hard to think about in the exam if you're a bit under pressure. We're only talking about this first section. And this first section is 180 on the axis. But they have just told us that it is not going to be 180, that it is actually going to be 720. It's been stretched out as a lot longer time period that it's got like this. So it looks like it's been a stretch in the x direction. It is a stretch in the x direction of scale factor 720 over 180. 720 over 180, I know, is 4. It's 4. So what does this mean that B has got to be? Everyone's telling me in the chat already. That means that B has got to be 1/4. So B is 1/4. There's no method mark for that. There is a method mark and a mark for alpha. So this bit is 2 marks. That's 1 mark. And that is 1 mark. It does ask for the complete equation of the model. So I'm going to do a final thing and say that h is equal to 50 sine of 1/4 t plus 1.15 degrees. it's weird because I was expecting there in this question to be some stuff to do with the harmonic identity, the like r cos alpha plus, you know, that stuff. I was expecting that. It's not in this question. It's literally just a normal trig question. This is year 12 trigonometry that we've got here. Definitely don't need a plus or minus 50 for this thing that we've got. There isn't really a more algebraic way to get to a quarter. This is like, I mean, not really. I thought about this before I started the live stream, like literally like 10 minutes before. I was like, I don't know if there's a better way of doing this. I think this is the best way of thinking about this part. Hassan said, I do recommend looking at the International EdXL papers, but you won't be able to do all of the questions. You'll only be able to do some of those questions that you've got here. And Hannah says, how would you think to do this in the exam? I think it's about what I did at the very beginning. When I saw this, this equation that was here, right? I said, oh, cool, it's a sine graph. Oh, it's had something else happen to it. That looks like it's something to do with transformation. So I kind of got, before I like dived into the question, I said to myself, I wonder what this topic is, and I wonder how I can connect this into things that I already know about, okay? That's how I want to sort of think about some of these things that we've got here. And then the last part says, explain why an equation of this form, with this little extra part with a plus d, where d is a positive constant, would be a more appropriate model. Sometimes I find myself staring at these questions for ages and being like, I don't know, like I'm not sure about what it means. And then you just try and think like logically, what might this actually mean here? So it does say something that this is coming down. You can even see it on this graph that we've got here. It does mean at some point the passenger is touching the ground, whereas clearly if the passenger is on a Ferris wheel, that Ferris wheel is never going to touch the ground. It's going to be scraping the ground that we've got there. So for part B of that question, the reason we're going to say that this might be a more appropriate model is because in the original model, the passenger touches the ground. The new model has them always above the ground. Which is more realistic. But I'm scarred by the fact that when I did the exams last year, I dropped my 1 mark on a worded question. I just get scarred by the worded questions. So annoying like this. If the wheel was built below ground level, maybe, but I think it does say something in the question. I mean, it doesn't really make sense. Anyway, we'll check that we've got this right. The minimum height of the passenger above the ground was 0 meters, or adding d means the passenger does not touch the ground for this. And there's really very little method going on for this. Like I said, the method mark only came from this section that we've got here, okay? So this is often a part where I mention some other things that I also do on my channel. Obviously, you've got my live streams, you've got my chapter summaries. Tell me in the chat if people have been using my chapter summaries. I'd love to know what you think of my chapter summaries, because I put so much time and love into making those. I really hope that those are things that you guys are finding useful. The other thing is I've sold out all of the tickets for the live session for the in-between Pure 1 and Pure 2 session, which I'm doing on the 7th of June from 9:30 to 12:30. So all of those tickets have gone for the live session. However, the recording is also £15. You will get it by about 2 or 3 o'clock on that Saturday. So you can use those videos on the Saturday evening, Saturday afternoon, and then you've got Sunday, Monday, before we have the exam happening later on in the week. So if, you know, when you do paper 1, you know what topics have come up in paper 1, it then helps you to prepare for paper 2. I'm going to take a lot of that work on board. I am going to only try and use questions that you have not seen before, using questions from other places. Live streams that I do, I just do standard past paper questions. When I do my aiming for A star sessions, or when I do the in-between session between Pure Paper 1 and Pure Paper 2 with that kind of predicted topics, I will only try and find questions, that are fresh, you have not seen before, so feel unfamiliar and kind of give you that last push before the exam. So if you're interested in that, that is linked in the description, £15 for the recording, and also my Pure A and Pure B session, which are also recordings, £15 only. Again, it's like 4 hours of content. I know it's annoying when someone's selling you stuff, but I genuinely think these things are useful for you. If you don't want them, you don't have to have them. My live streams are great. I only say it because this is the way I get to fund my job of being a YouTuber. YouTube doesn't give me enough, so being able to do these classes and you coming to them and paying for them means I get to do this as my job and do these live streams for fun. Anyway, enough from me on that. I really appreciate you listening to all of that kind of stuff that we've got there. So people are saying that they liked my summary videos, which is really good. So I'm just having a quick scroll up from that and just getting a bit of a like, yeah, this is good. Yeah, I'm pleased people like these. It's making me feel really happy. I really enjoyed writing my own questions for that as well. Really enjoyed writing my own questions for this as well. Will there be anything for further mechanics? I don't know. I've already done further mechanics. Further mechanics, the aiming for a star session has already happened for this as well. Parametric integration can come up in either paper as well. I'm not going to be doing a live stream for decision. I am very sad to say. Okay, let's get back to some maths now. So this is a question 15 from 2022 paper 2. And again, you're like, oh my gosh, it's a geometric series. This isn't trigonometry. But of course, they love to take trigonometry and just like sprinkle it like all over the exam paper so that there's just trig all over the place. It says the first three terms of a geometric series are this, this, and this. Show that this thing is true. Okay, well, when I see a show that, I don't tend to look at it to begin with. I tend to think, what have I got in front of me? Now, what do we know about geometric, not trigonometric? What do we know about geometric series for this stuff? This is a way for Family Guy highlights, okay? Yeah, very good, Jake. Nice to see you in the live stream again, Jake. There is a common ratio. Oh, I love what Big Lee has said. Term 2 over term 1 equals term 3 over term 2, the common ratio. Now, when you think about a sequence that you've got a geometric series, if I had something like 3, 15, oh my God, am I even going to be able to do this? 75, he reaches for the calculator, 375. We can see what the common ratio is. And the way that you can kind of set this up is we can say that 15 divided by 3 is the same as 75 divided by 15, which is the same as 375 divided by 75. They have a common ratio, which is 5, as long as I've not made up any mistakes for this kind of stuff. So we can now just apply that to this thing. And if it was an arithmetic sequence, we wouldn't be doing them divided, we would be doing them subtracted. So this means that 5 plus 2 sine theta divided by 12 cos theta, the second divided by the first, is the third divided by the second that we've got like this. Geometric series for part A, finished. Now we're going to just solve the equation, or at least get towards solving the equation that we've got there. Some really fantastic responses in the chat today. People are really, I can tell you're all at that stage of getting very, very close to being ready for the exams. In fact, I'm sure many of you are probably ready to do the exams already. So I'm going to multiply that up there and that up there so that we have 6 tan theta. Can you tell me what the right hand side simplifies to while I expand these brackets, please? I want to know what the right hand side is going to simplify to. I'll do the 6 and the 12, I think. Very, very quick from Rudy. Well done. Yeah, I think someone just didn't spot the extra 12 there, but that's not a problem. Don't delete anything from the chat. I like seeing what people thought of these things originally. So we get the 72. Tan theta is sine theta over cos theta, and we're multiplying it by cos theta, so the cos theta disappears. So that's 4 sine squared theta. 20 minus 72 is minus 52 sine theta, plus 25 equals 0, which was the thing that we were aiming for at the top of that page that we've got there. Now, you kind of knew what was going to come next in the question. We've got an equation. Obviously, the next thing we want to do is to solve the equation. But there is something quite important when it says this. It says, given that theta is an obtuse angle measured in radians, solve the equation to find the exact value of theta that we've got. Okay? So, I know it says this thing at the top. In this question, you must show all stages of your working. It's only a 2-mark question. They can't possibly have a mark for factorizing this, but I'm going to solve it, and we can technically pretend to factorize it if we want to. Now, you actually only get the mark for just saying from the calculator, you get that sine theta is either equal to 1/2 or sine theta is equal to 25 over 2. If we wanted to pretend that we hadn't used the calculator for this, well, this is clearly the sine theta being equal to 1/2. That's clearly sine theta minus 1. 2 sine theta minus 1, and this one would be 2 sine theta minus 25 equals 0. So we've actually factorized it and just pretended that we factorized it. This one, of course, has got no solutions. This one, when we do the inverse sine of a half, well, that's 30 degrees, or pi over 6. Remember, to get the second solution for sine, you do pi minus the answer. Pi minus pi over 6 is 5 pi over 6. And I'm going to take this one, because this one is obtuse, whereas this one is acute. So the answer is that sine is equal to 5 pi over 6 that we've got for this. Yes, if you ever need to, you can write out the quadratic formula to kind of do that instead of doing it as like a factorizing or anything like this, okay? So you are allowed to use the calculator in this one. It was only a 2-mark question, but just in case there's something that's about quadratics and you kind of don't do, you kind of rely on the calculator to do it, it's just worth kind of knowing that if it says using algebra, you really do need to do this. So we're now going to show that the sum to infinity, we're finally back in geometric series land here. We're going to say that the sum to the series can be expressed in this form. So the sum to infinity, this is from the formula booklet. From the formula booklet, it is a over 1 minus r, okay? So I'm actually just going to re-examine the sequence that we've got, or the series that we've got for part C. I think it was, what was the first term? 12 cos theta. Then it was 5 plus 2 sine theta. And then I think it was 6 tan theta. Yes. So I'm just going to substitute in here that theta is 5 pi over 6. We already know that sine of 5 pi over 6 is a half. We worked that out. Cos of 5 pi over 6. I'll just do that on my calculator. Got to make sure I'm in degrees, in radians mode. 5 pi over 6 cos the answer, that's minus root 3 over 2. Okay, I'm just going to start subbing in. So the series is minus root 3 over 2 times 12. It starts off as minus 6 root 3. The second one is 5 plus 2 times a half, which is 6. The third one is 6 tan of 5 pi over 6, which is minus 2 root 3. So we've identified that a is minus 6 root 3. The common ratio is 1 divided by the other. That's 6 divided by minus 6 root 3. So I can put this on my calculator because you could, in theory, just rationalize this in your head as well. 6 divided by minus 6 root 3 is minus root 3 over 3. So the sum to infinity is a over 1 minus r, which is a over 1 minus root 3 over 3. So it is minus 6 root 3 over 1 plus root 3 over 3. Now, can I put this in my calculator? Can I put this in my calculator to get my final answer? I mean, you know why I'm asking this question. It's ridiculous. This is a show that question where solutions relying on calculator technology are not acceptable. But the key thing here is show that. This is where I lost one of my marks in my further pure exam. They haven't assessed rationalizing the denominator. So they want to see this. They want to see rationalizing the denominator. 1 minus root 3 over 3 over 1 minus root 3 over 3. And then after that, I don't care. I'm just going to put it in my calculator. So minus 6 root 3 divided by 1 plus root 3 over 3. And we get 9 minus 9 root 3. The examiner thinks I've rationalized the denominator, but I have not done this. Oh, I think there might be a bit of... Maybe I'm not getting enough. Hopefully the stream is okay. It's saying that my stream status is not very healthy at the moment, but we've got lag. Why is this happening? Okay, are we back? It seems fine now. Okay, good. The stream health is saying it's not good. I don't know. We'll see. We'll continue. If it gets worse, I may have to kind of stop with this. Good. I hate it when it does stuff like this. It's so stressful. Live streaming, you think it's just going to be a load of fun, and then suddenly it is stressful. Okay, cool. We're good. If you need to, skip ahead. You will get to the same point. I've kind of been around here for a while, okay? So let's continue. Now, the examiner thinks I have rationalized the denominator. I just used my calculator. And they wanted it written in a particular form, didn't they? They wanted it with k1 minus root 3. So k is obviously equal to 9. So this is k1 minus root 3. So k is equal to 9. I remember when I first did this question, the thing that I definitely didn't do was rationalizing the denominator. We are back in excellent condition for this. It's saying excellent condition on the stream. I did not rationalize the denominator manually, and I don't think I read this very carefully when I first did this question. I didn't read that it was an obtuse angle for this thing as well, okay? I actually have never hired anybody else to do tutoring before. I probably do need an Ethernet cable, but my internet is downstairs by the front door, so I'd have to be like live streaming in my living room. So I've got these like, has anyone ever used these like extra like Wi-Fi boxes? This one's like an Eero one. The Wi-Fi is good, it just sometimes just drops like this. An obtuse angle is the one that's this one, 5 pi over 6, and the acute one is pi over 6. Pi over 6 being less than pi over 2, or less than 90 degrees for this. Okay, so we did get all this right. Let's do the last question because this is going to be a tough one. Okay, fun. Parametric. Okay, this question has so much in it. It has parametric equations. It has differentiation. It has normals. It has Cartesian equations. And it has a range of values for solutions that we've got here. This is a tough question. Very, very few people will be able to get this full as question. And also I want to talk to you a little bit about some exam strategy. When you come to any of my other sessions as well, if you do come to like a recording of them or you've been to any of my live sessions, we often talk a lot about exam strategy. It's not just about can you do the maths. It's about thinking like calmly in the situation, thinking where are the marks here that I want to be able to get. I'm telling you right now, these 5 marks at the end are very challenging to get. However, these are quite simple in some ways. They're quite simple to get those 7 marks. And to get 7 out of 12 in the last question of an exam paper is really, really good with this. This is a tough question. I'm hoping that if you see something similar to this, it might be helpful for something for you to think about in the future, okay? So, figure 6 shows a sketch of the curve with parametric equations x equals 2 tan t and y equals 2 sec squared t plus 3. And they've told us a domain that we've got here for t. The amount of times I will do a question, and I did it when I've looked at this in the past as well, normal, I just often forget. So even if I wrote something down on my question like this, normal, give yourself a little cue in the future to know what you need to do is a normal. Using parametric differentiation, notice how they've said using parametric differentiation. In other words, do not find a Cartesian. When I talk about parametric questions, the majority of the time, they want you to stick in parametric world, unless there's a cue for it to kind of move on, which is obviously going to happen later on in this question. So we have, does anybody want to remind me? Oh, this is crazy. You guys are the best. I'm literally was about to say, does anybody want to remind me how to find dy by dx? It's like there's a delay, right? When I speak, there's probably about a 5 or 6 second delay. It's almost like it's the other way around. It's like you're writing things and then afterwards I'm responding. Anyway, what I was going to say is how do we find the gradient? Because obviously if we're doing the gradient, we want to find this. And people have already told me that it's dy dt divided by dx dt for this. You guys are fantastic. Now, y is equal to 2 sec squared t plus 3. I'm going to write it like this, 2 sec squared t plus 3. And differentiating this is not easy. Now, in the formula booklet, we know that sec x differentiates to sec x tan x. I'm hoping that you've memorized this, though. I probably should do a poll being like, who has memorized this? So when I differentiate this, I have 2 sec squared t. I will pull the power down and reduce the power by 1. So I'm going to pull the power down, so it becomes a 4. I will reduce the power by 1, but I need to multiply by the derivative of sec t, which is sec t tan t. The plus 3 obviously goes to nothing at all. So it is 4 sec squared t tan t. And x is 2 tan t plus 1. 2 tan t plus 1. I think we know what tan differentiates to, right? Oh, I'm so thirsty. Tan differentiates to, very good, sec squared t. So it'll be 2 sec squared t, and the 1 goes to nothing, which means that dy by dx is the y part, 4 sec squared t tan t, divided by the x part, which is 2 sec squared t, and we breathe a sigh of relief because we get rid of that horrible sec squared t, and we just end up with, I'm sure I'm writing this under my picture, 2 tan t. Now, remember I wrote this in big letters. We're doing the normal here, and we're finding it where t is equal to pi over 4. So, when t equals pi over 4, dy by dx is 2 tan of pi over 4. Tan of pi over 4 is tan of 45 degrees, which is 1, so it's 2. So this means that the normal gradient is the negative reciprocal. We also need to find out the x-coordinates and the y-coordinates. So the x-coordinate is 2 tan of pi over 4 plus 1, and the y-coordinate is 2 sec squared t, 2 sec of pi over 4 squared plus 3. Now, I think this is probably going to be quite useful throughout this question, that we have, I'm just going to write these things down so that we have them kind of recorded, because I think they're useful. It's that tan of pi over 4 is 1. Cos of pi over 4, from memory, is 1 over root 2, which means sec of pi over 4 is root 2 over 1. So sec squared of pi over 4 is 2. It just saves me a bit of time with like having to type loads and loads of these things again and again and again. I do personally recommend memorizing what tan differentiates to and what sec differentiates to. Those are kind of the bare minimum of what I say to my students. You do need to have those memorized. So the x-coordinate will be 2 plus 1, which is 3. And the y-coordinate is going to be 2 times by 2 plus 3, because I'm using that fact for that bit there, okay? Which is 7. So now I have the gradient, the x-coordinate, the y-coordinate. Of course, we're going to do my y minus y1 equals m brackets x minus x1. So y minus 7 is equal to m x minus 3. And normally, they do have it as y equals. They don't often have it in that form, but they do have it as a y equals for this question. So this is going to be y equals minus a half x plus 3 over 2 plus 7. This isn't the hard part of the question either. 3 over 2 plus 7 is 17 over 2. So y is minus a half x plus 17 over 2, which was the thing that they wanted us to show. Gosh, not there, but to show at this point, okay? Let's see if there's anything else that's going on here. Okay. Good, I don't think I've missed anything in the chat that was that important. We are coming up to 1,000 votes on hat or no hat. Obviously the hat has stayed on this whole time. It's quite interesting, the ratio of this. Maybe I should have done it in the ratio of according to how long I've been on as well. This is the 2022 paper. Now, it does say, show that all points on C satisfy this equation. There are many, many ways of doing this. Many ways of doing this. However, a way for me that feels like the easiest is when it says it satisfies the equation. That actually feels like, to me, what I can do is I can just take these things, here and here. I can take that, and I can actually just substitute them in and check that it works. If you don't want to do it that way, you can connect them together using the 1 plus tan squared equals sec squared identity. But I'm actually going to start off with, I'm going to take the x part, I'm going to substitute it into, oh my gosh, not into that thing at all. The whole thing I was talking about was this, by the way, guys. I was talking about the wrong thing that we've got. So we are talking about substituting x into this thing. I'm going to show that it satisfies that equation. Apologies, when I was talking about this part, I did not mean it for this one. So I'm going to show that when it subs in, it works. For part B, y is equal to a half x minus 1 squared plus 5. And a quick reminder is that x was, what was x? 2 tan t plus 1. And y was 2 sec squared t plus 3. So I'm going to take that, sub it in there. Let's go. Y is a half of 2 tan t plus 1 minus 1 squared plus 5. So the plus 1 and the minus 1 cancel. It's a half of 4 tan squared t plus 5. So y is 2 tan squared t plus 5. And we know from the trigonometric identities that 1 plus tan squared is sec squared. So tan squared is sec squared t minus 1. So I can use that to substitute it in here. That is y is equal to 2 sec squared t minus 1 plus 5, which is 2 sec squared t minus 2 plus 5, which is 2 sec squared t plus 3, as required. So I can say, hence, you don't even have to say this, hence y equals a half x minus 1 squared plus 5, okay? There are many, many, many ways of doing this kind of thing. You can either substitute it in, you can connect them with a different formula, however you want to do this kind of stuff. This is just the approach that I take for this kind of thing. This is the last question that we're doing in this one. Yes, you should only really do this for verify and satisfy questions. If it was just a full show that question or like find it, there are, I don't know, this, it's because it says show that it satisfies this equation that we are good for this. And here comes the real fun of this whole live stream. It is this last part of the question that has now got nothing to do with this part. It's got nothing to do with this normal, or kind of has something to do with the normal, but not really. I'm not going to scribble that out. Let's leave it. The line with equation y equals minus a half x plus k, where k is a constant. So this line here is y equals minus a half x plus 17 over 2. So it's parallel to that line. It intersects the curve at 2 distinct points. Find the range of possible values of k. All right, so here is the line. And this line has to stick with that gradient of minus a half because of the fact that there is a minus a half in front of the x. Obviously, there is this plus k, that thing I've highlighted in blue, which is going to respond to the point where it is crossing the axis, right? Now, when I take this red line, I want it to cross the curve in 2 places. And the reason it's not going to be the entire curve, well, why is actually, maybe I can ask you this question. Why is the curve C, which they've shown on the diagram here, why is it not the entire quadratic curve? Why is it not the entire quadratic curve for this? Very good. People are on this. People are understanding it is because of the fact that we have this domain for t that we have got here. Okay, we've got this domain for t. So it's not the entire curve. It is literally just this section that we've got. So it is going to cross twice. It's only crossing once for this whole section like this. It is going to cross twice. Oh, there. When it passes through, I knew it was going to move. When it passes through that point, it has 2 solutions, okay? That's one of the things we're going to work out. So I'm going to say when it passes through, is this C? So if it's that shape, when it passes the X, it has 2 solutions. Because it goes through like that, doesn't it? So I need to find out what the coordinate of that part is. So at this end that we've got here, this, I think, is when t is equal to minus pi over 4. It makes sense it's going to be the minus pi over 4 because it's going to go in that kind of order that you've got. So I'm going to substitute minus pi over 4 into this. So 2 tan of minus pi over 4 plus 1. So x is minus 1. So that coordinate is minus 1. And I'll substitute it into the y part. So I shall do minus pi over 4. I'll do the cos of that. I will take the reciprocal of that. I will square it. I will times it by 2. And I will add 3. I've basically just been substituting t equals minus pi over 4 into this. And we get that this is 7. So I now know that minus 1, 7 is on that line that we've got there. I knew that it was minus pi over 4 or pi over 3. It had to be one of those two values at the extreme end of this curve. And when I'm talking about the extreme end, I'm talking about this end or this end. It just kind of made sense that that one was minus pi over 4 because it was on the left. But also, if you substituted pi over 3 in, you wouldn't get a negative x value. And clearly, it's to the left of the y-axis. So the x value is negative for that one that we've got. Okay. So I know that minus 1, 7 is on the line minus a half x plus k. So that is minus 1, 7 and is also on y equals minus a half x plus k. So I can substitute that in. 7 is minus a half times x plus k. So 7 is a half plus k, which means that k is 7 minus half, which is 13 over 2. So if k is less than or equal to 13 over 2, we will have two solutions, because when k is equal to 13 over 2, it's got those two solutions. If it's less than that, it's still going to have two solutions until we get to that bottom part where it is a tangent. So we now need to find out where is this coordinate where it is a tangent at this part. This is a very, very, very challenging question. So I'm going to take the Cartesian equation and I'm going to differentiate that to find out when it has a gradient of minus a half, okay? If you're struggling with this, this is very, very normal to do this. It's very normal to struggle with this. So I'm going to find the point on C which has gradient minus 1/2 so that y equals minus 1/2 x plus k is a tangent and only touches once. Now I know you're thinking, well, we need it to touch twice. That's why I'm going to make k bigger than that value, so that if it's bigger than that, it will touch it twice. So I am now going to actually use the Cartesian equation. Do I need to use the Cartesian equation? I suppose I don't even need to use the Cartesian equation. I could actually use it with this original one if I wanted to. I could use it with this original one if I wanted to. I'm probably just going to use the Cartesian. So when I differentiate this, was it plus 5? I think it might have been plus 3. No, it was plus 5. I'll differentiate. So I will pull the power down so it becomes a 1 and reduce the power by 1. That's it. And so the x coordinate when dy by dx is minus a half, I'm trying to find out where it is where the gradient is minus a half, is x minus 1, which means that x is minus a half plus 1, which is a half. And when x is equal to a half, y is equal to, substituting it into this thing, a half minus 1 squared times a half plus 5 is 41 over 8. So I now know that 41 over 8 and a half are on the line y equals minus a half x plus k when it is a tangent. So 41 over 8 is minus a half times a half plus k. So I'll do that plus a half times a half. We get 43 over 8. So we know that k has got to be greater than 43 over 8, because if k was equal to 43 over 8, we have that it is a tangent and only crosses once. If k is bigger, it will cross in 2 places. You can see it crossing in 2 places until it gets to this point. If it was any higher than that, it's only going to cross in one single place. So that's why it's got to be in between that red dot and that blue dot for that value that we've got there. This is a really, really, really challenging question. So we get that the final answer, I don't think it wants it in set notation, was that k is between 43/8 and 13/2. Does it want set notation? No, it doesn't. So I'm going to talk about this one final time because this is basically the end of the live stream that we've got here. So we did get this right, 43/8 and 13/2. We were trying to say, because this entire curve didn't exist, okay, let's get rid of all this stuff so I can kind of see what's going on. We were saying that only this section of the curve was there, and we were trying to find out when this line crosses the curve in two places. That means it will cross it in two places as soon as it touches this part here. As soon as it touches that part, it's going to cross in two places. But we can't just say anything lower than that because clearly it doesn't touch anything below. If it's at a tangent, it will touch it at one place. So as soon as it's above the tangent and below that yellow point, it is touching in two places. And that is kind of the approach that we were taking for this very, very, very challenging question that we have got here. So I am going to finish up because I need to make sure about an hour I think is good for this. Someone has said, what would this look like if it was in set notation? You can just say k dot dot and that. Don't need to fuss around with anything else. You don't need to say where k is a real number. You don't need that. Mark schemes will accept it exactly as I've written here. I won't tell you things unless they're things that are accurate and could be used here for this. So if that last question was too much and like crazy, let's think a little bit of exam strategy for a second. Do you think it is smart to spend 20 minutes trying to do these 5 marks to find the range of possible values of k? Or do you think those 20 minutes might be spent better elsewhere, checking to see if you've made mistakes on anything else? That might be something that's better, okay? Someone has said, could I use the turning point of the Cartesian equation? No, because if it passes through the turning point of the Cartesian, like this, the turning point is here. If that line passes through it, it's very, very hard to see. But if it passes through the turning point, it does actually cross it in two places. So we need to go even more extreme than the turning point. It needs to be where it's a tangent, which is slightly to the left of that turning point. So you do have to be really, really careful and think to yourself, am I trying to get 100% here? Am I trying to get an A? Am I trying to get a B? Am I trying to get an A star? What am I trying to do in this exam? And I know this seems like very strange advice for a teacher to be giving, but this is a strategy. This is a game that you are playing to try and get as many marks as possible that will leave you with the grade that you want. When I did the exams, of course, I was trying to get everything. I'm a maths teacher. I need to try and get 100 out of 100 when I do these papers. You are a slightly different situation. Are those 5 marks worth you spending a long time on? In my opinion, they might be better spent on question 2, where you did a silly mistake, where you put a negative in for the binomial expansion when you didn't need to. It might be better for you to spend 5 minutes checking over your modelling answers, substituting it into a calculator. I know that we all get exam papers back. I used to give exam papers back to students, and I'd be like, you dropped like 4 marks in the first 2 questions. What's going on? So kind of think like how you should think about that exam strategy for this kind of thing. You guys, we got over 1,000. We got 1,100 votes. Absolutely brilliant. The hat is staying on. 2/3 of people wanted the hat staying on. The hat. I wonder how bad the hair looks now that it's been under the hat. Let's have a look. Not too bad. Not too bad. Okay. So I might do, I'm going to do some other lives. I might do one tomorrow. I am definitely doing a live the day before the exam. I want it to be a really big live stream where we can get ourselves ready for doing that exam. And I don't know, what have I done so far? I've done hard questions from the end of the paper. I've done a calculus live stream. I've done a trigonometry live stream. I'm going to see if I can actually start here, a Q&A. So I'm just going to say, what other themes should I do for a live stream? I don't know how this will work, but let's try out some new features here. So if you've got any ideas for a live stream, you can let me know and see if there's any questions that come up from that. Okay, I might have to refresh this page because it's looking a bit crazy. There we go. Bu akışlara çok seviyorum. Bunun için teşekkür ederim. Akışlara çok seviyorum. Akışlar. Akush. I don't know what akush means. But it's saying that you love something, and for this reason, thank you very much. So, yeah, most of my videos are good for OCR that we've got there as well. Modeling. Ooh. I could do modeling stuff. So I don't know how the Q&A works. I've never used one of these Q&As before, but I have launched a Q&A. I wonder how that information will come through to me. Rayan Murali, if you want to find out about live streams, best thing to do is to have notifications for YouTube turned on, and to just make sure that you get notifications for my channel turned on. You don't have to have them on after that, but just over the next few weeks or the next couple of weeks, it's going to be useful for you to get notifications about this kind of stuff. I never predict grade boundaries. Oh my god, my mum's back. My mum is back. Bless her. She says, good luck everyone from Bicen Maths' greatest fan. Yeah, I am going to need to go back to Turkey. I think I might need to go back to Turkey to get this sorted out. I talked about this in another live stream. I need to get this hairline's receding. The hairline is receding faster than... God, I can't even think of anything. My brain is all to mush here. Okay, I'll try and just put in some hard questions, I think. The live stream the day before the exam, I'm probably going to do about like 4 o'clock so that we can get like really focused for it. And I did a home workout today. People saying no gym today. I did a home workout. I am going to do minoxidil on the hairline. That's coming up. That is coming up. In fact, I'm going to go and order that when I get off here. Hairlines don't define you, sir. Amazing. Yeah, everyone, can we all say thank you to Mama Bicen, because she's just the best. She's the best. And it's just so funny. I know I said this in the last live stream if anyone was in it, but like, no matter how old you are, your mum will always treat you like a kid. So she still treats me like a kid, even though like, obviously I've been a teacher for all this kind of time. And she's amazing. She is amazing. So I'm really pleased that she's been here as well. Okay, I'll figure out, I'll come up with an idea for what to do with the live stream. I don't know if this Q&A actually like came along or not. I haven't actually worked out how to do the Q&A properly. So we will figure it out. I'm going to close the hat poll down. And the hat went really well. And we'll see how that kind of goes. So 66% wanted the hat, 33% no hat. 1.1k votes that we've got here. No, my in between live stream. So I'll do a live stream before the second paper, but it will just be random questions. The session that I'm going to do on the 7th of June, I'm going to put a lot of time into selecting questions that you have never seen before, hopefully never seen before. And it will be on Zoom. The recording of that will be from Zoom and stuff. And last year people said it was really worth doing. So if you're not sure about it, I've set it at a price that I hope means that people think like, you know what, I'll give it a go. It could be something that's good to focus my revision. And again, if you like the way I teach, my Pure A and Pure B session that's also linked in the description, I'm very proud of those sessions. I put a lot of time into these. So the second I've got people paying for something, I have to make sure that it is worth people's money. People work hard for their money, and I have to make sure that it is it's something that's worth it for them. So I'm very proud of them. I think my average rating is over like 4.83 out of 5 from like loads and loads and loads of reviews. Everybody gave it a 4 or 5 out of 5, apart from one person out of like 400 reviews. One person gave it a 3 out of 5, and I read the comments that they said, and they were like, thank you, Mr. Bicen, this session was amazing, I really enjoyed it. And then in the like anything to improve, they literally had like nothing to improve, and I was like, well, why did you give it 3 out of 5 then? Why did you give it 3 out of 5 and warp my stats like that? Anyway, I'm not bitter, but I am very proud of those sessions, and people are really, really positive about that kind of stuff. They're completely anonymous as well. The reviews of this stuff are all anonymous. I'm expecting the exam papers to feel quite similar to 2024 in terms of difficulty level that we've got there. Yeah, isn't it funny how like you can have like so many amazing comments from these reviews and stuff, and you get one of them where you're like, oh, why did you give me a 3 out of 5? And that's the only one that you remember. The human brain, it's just so stupid, the human brain. I need to remember, people really like those sessions. So if you're interested in them, I know loads of people here have come to them. You've probably heard me talk about this tons and tons and tons. So haters gonna hate. You are right, big man. It's very, very true. Very, very true. Okay, I will do a live stream the next couple of days. I really enjoy this. Oh, Lily is the first live stream that you've ever attended, and it was great. Thank you so much. I will be doing more of these kind of stuff. I love doing these things. I'm going to go and enjoy my Sunday roast, vegetarian Sunday roast, of course, in Manchester. And when I started, it was pretty grey, but it's getting kind of sunny now. And hello to my mum. I don't know if she's still watching, but whatever. Yeah, you can access old lives. When you go onto my YouTube channel, there's different tabs along the top. So there's like playlists, videos. If you click live, loads and loads of live streams there as well, okay? I did speedrun a paper before and then got violated by R2 Drew 2, who was like, okay, I'll speedrun a paper. And he did it in like half the amount of time that I did. But R2 Drew 2, he'll know this. He is an amazing YouTuber, by the way. So I'm only saying this as a joke. His handwriting in that live stream, oh, he was going too fast. He couldn't keep his handwriting neat enough. If you're watching this, R2 Drew 2, this is just very gentle banter there, because obviously I think you're fantastic. I think your videos are incredible, and he's a brilliant teacher. If you're ever looking for any help with some really, really challenging questions, R2 Drew 2 is a fantastic YouTube channel to go and look at that kind of stuff. But yeah, he totally violated me when he did he did a speed run, and I was like, whoa, okay, that was fast. So yeah, he knows what he's saying. I'd love to do a collab with R2 Drew 2. He's a great teacher, really great teacher. Let me know if there's anyone else I should do a collab with, actually. I'd be interested in doing that. Anyway, this always happens. I finish the live stream and I sit around just chatting for ages because I enjoy doing that. The calculators I use the FX CG50 at the moment because this is what all of the students are using. Soon, schools will be buying the CG100, so I will be using the CG100. I like to use the same calculator that you are when you're doing your exams, and soon enough everybody will be using the CG100. But this calculator, which is my FX 83 GT Plus, I used it so much over the years it ran out of battery and I had to change the battery. You can actually take the back of it off. I think there's like an old post of me talking about that as well. So yeah, eventually I'll be using the CG100, which I really like, and I will be always using this calculator because I love this calculator so much. Okay, I'd love to do something with TR Maths as well. TR Maths is great. Don't recognize some of these other usernames, but all good. Cool. Okay. Right, let's go and have a nice Sunday roast. Hope you have a nice evening, guys. Do take some time off. Do have a nice little rest. And oh yeah, and Zishan is great. I'd love to do something with Zishan. No. I would, if you've got the CG50 already, stick with the CG50. It's only because the CG100 is eventually going to be rolled out to everybody. So it's not something that's like, oh, you have to upgrade to this. It's just like in time, that's going to be the calculator that people will be using for this as well. Okay. The Turkish learning is going really well. I spent so much time yesterday doing Turkish. I've got these little books where they have like a story that's in English, and then on the one side it's in English and the other side it's in Turkish. And I'm now actually getting to the point where I can, gosh, that's the English side. I'm getting to a point where I can read the side in Turkish and I can actually understand what's going on. Not perfectly, but I'm getting there with it. But the stories are from like 30, 40, 50 years ago, so they're really weird stories. I've read my first full book of that in Turkish. And then at some point in the summer, I want to start doing these books as well, which is obviously some maths books in Turkish as well. We've got, I don't even know what this stuff says. But we've got like logarithms, differentiation, logaritma diziler, trigonometry, döşünümler, limits, and then integrals as well. So I'm going to be doing some of that over the summer because that's the way I like to relax. Anyway, I am actually going to go now. I'm actually going to go. There's still so many people here. What are you all doing here? I would try and do a stream in Turkish. Yeah, the class quiz is still good. You don't need the CG. Right, tell me to leave, okay? Tell me to leave because I'm enjoying staying here. But tell me to leave. Yeah, someone said, where's the hat? Need to get back onto it. Okay, I need to leave. Guys, have a great one. I'll see you in a live stream very soon, okay? Definitely the one before the exam. That's going to be a big one. It should be really, really fun. Have a good day. See you later, guys. Bye now.